Good morning, everyone. We appreciate you joining us today to delve into the Stingray Electronic Warfare Training System. Stingray is an acronym for Signature Training, Interference, Negation, Geolocation, Replication, and Evaluation. This initiative is a collaborative effort between the Office of Naval Research and Aspen Consulting Group. At Aspen, our ethos is solving problems you didn't even know you had. Before we explore Stingray's technical specifics, I will give a brief overview of Aspen Consulting Group. We've been operational for 25 years, serving as both a prime and a subcontractor. Our core technical capabilities encompass radio frequency, design, development, and production, alongside signals intelligence and electronic warfare capability and system development. Our technical lineage is significant, with a 15-year history of conceiving, designing, developing, and testing SIGINT, EW, communications, and test systems for entities including the Army, Navy, U.S. Marine Corps, SOCOM, Five Eyes, and coalition nations. Over 1,600 such systems have been deployed globally. Specific project highlights include our work on the following efforts: Navy SBIR Topic N232-108, where we built and delivered 4 prototypes under the Phase 1 effort, and they have been employed by multiple U.S. Marine Corps units, already with positive reports. Army SBIR Topic A18-109, Radio Direction. Finding obfuscation, we generated 2 major spin-offs that were successfully tested at Vanguard 2024 and have transitioned them to other programs. Furthermore, under Army STTR A19C-T005, Adaptable Tactical Communications, we demonstrated 10x spectrum scanning with artificial intelligence and machine learning, and directed communications channel reconfiguration. Our key resources include significant IP derived from prior SIGINT and EW system developments, access to local over-the-air test ranges and test chambers, and an RF propagation tool/channel emulation, testbed for comprehensive mission planning, development, testing, and training. Geographically, we're strategically located within driving distance of ONR, NRL, Quantico, Aberdeen Proving Ground, and numerous major defense companies. We're also keen to partner with other contractors for large-scale production and field service support. The impetus for Stingray stems from a critical need to develop low-cost hardware capable of remotely manipulating command and control gear to accurately mimic electronic warfare attacks during Marine Corps training and exercises, particularly those conducted at home stations. The desired end state is a modular, low-size, weight, power, and cost multifunction transceiver. This transceiver must be easily deployable across the force for the generation of contested and electromagnetic spectrum operations environments, and it needs to be seamlessly integrated into the U.S. Marine Corps training and testing infrastructure. Expected transition partners are listed on this slide. This directly addresses mandates from high-level Marine Corps guidance to include the 38th Commandant of the Marine Corps Planning Guidance. Explicitly states the need for C2 in a degraded environment, highlighting that our communications nodes will be hunted and targeted. U.S. Marine Corps Force Design 2030 emphasizes developing a distributed, operations-capable force that can mass effects while minimizing signature. Furthermore, the U.S. Marine Corps' Science and Technology Objectives and Strategic Plan and identifies specific requirements relevant to Stingray's capabilities, including direct and planned military deception, 3MEF-MAG-TF tactical warfare simulation training, MOS, and skills progression training, understanding the implication of cyber effects, electronic attack, and understanding the electromagnetic environment. U.S. Marine Corps TCOM also highlights the need to replicate multi-domain EW and EMSO environments for ground forces, addressing the current lack of a simulation for EMSO and the inability to fully stimulate, link, and federate simulations with C5ISR systems. The overarching goal is to enable the force to deny, disrupt, degrade, and deceive in realistic contested RF environments, supporting virtual, chamber, field, and hardware-in-the-loop testing, tactical operations, exercises, and training. Our solution is Stingray, which leverages a modular, reprogrammable, low-swap-C software-defined transceiver. This architecture provides a contested RF environment for RF system training, enabling operators to develop crucial techniques to recognize and mitigate interference and jamming, and to practice the transition to alternative communications pathways. The system can be locally or remote controlled and interfaces to various processing, display, control, simulation, and testing architectures as part of a system of systems approach to electronic warfare training. This image depicts a deployed Stingray system providing primary, alternate, contingency, and emergency training at an OCONUS exercise. We've conducted extensive performance demonstrations of Stingray across multiple operational environments, achieving all intended objectives. These demonstrations included showcasing multiple waveforms and effects at various ranges, and validating the ease of programming, setup, and use of multiple devices. Notably, MCTS-SA units employed Stingray systems with minimal training overhead. We've successfully demonstrated remote control capabilities from Quantico and seamless integration with virtual simulation environments. The system has also exhibited a robust 8-hour battery life and demonstrated 2-channel 0.2 to 10 watt VHF or UHF operation. Our current status reflects continued progress. We have completed 4 Stingray units, with 3 already delivered to ONR and actively employed in multiple exercises and training events. The modular design incorporates 2 fully independent operational channels. We've delivered the user guide, embedded software, and GUI software to ONR, and critically implemented a REST API interface for straightforward integration with other systems such as Fightware and Ascot. AJF-12 number has been assigned, with DD-1494 approval anticipated in the coming month. We've also successfully implemented web browser and WinTAC interfaces and enabled GNU radio hosting. Current development efforts include a redesign of the RF transceiver card, amplifier, and GUI, along with the implementation of 2-channel receive functionality. Technical testing is strategically planned for the 4th quarter of 2026. Let's summarize the distinct features and compelling benefits that Stingray offers. Stingray provides a low SWaP-C electronic warfare training device, suitable for all test and training ranges, including outdoor, classroom, or lab, chamber, and hardware-in-the-loop test beds, for both field training events and home station training. It represents a significant cost reduction, being a fraction of the cost of existing systems, and is designed to look like a radio, not an electronic warfare system, for reduced signature. It implements modular, software-defined architecture specifically designed for growth and expansion, enabling support for additional applications and operational modes. The system facilitates training of the entire force with minimal resource allocation, and it significantly simplifies device setup, programming, and operation. Crucially, Stingray interfaces seamlessly with existing U.S. Marine Corps equipment and is integrated into the U.S. Marine Corps training, testing, and support infrastructure, including Fightware, Ascot, WinTAC, live virtual constructive training environment, and electronic warfare ground instrumented range. It generates high-fidelity electronic warfare effects triggered by time, location, or external inputs, utilizing pre-programmed parameters, on-the-fly generated parameters, or remote control. The most compelling benefits of Stingray are: Stingray directly addresses the limitations of existing electronic warfare training devices, which are characterized by high cost, large swap footprints, and expensive operational and maintenance requirements. Existing electronic warfare training devices are often complex to program and operate, necessitating specialized operators, and frequently fail to support the comprehensive range of attack vectors required for the full spectrum of U.S. Marine Corps training. Stingray's design directly mitigates these challenges. The transition pathway for Stingray is well-defined and progressing. The system has already demonstrated significant utility, being employed by multiple U.S. Marine Corps users during exercises and field training events, generating a strong demand signal for the current limited assets. We have proactively incorporated numerous user-requested upgrades. Phase 3 funding is essential for productization and full transition, including comprehensive testing and qualification. The Office of Naval Research is our primary transitions advocate. We are also seeing considerable interest from the U.S. Army, specifically PMEW&C and DEVCOM C5ISR Center. The warfighter value delivered by Stingray is substantial. It empowers U.S. Marine Corps RF equipment operators to develop critical tactics, techniques, and procedures for recognizing and mitigating interference and jamming, and to practice the seamless transition to alternative communications pathways. This directly enhances operational security and survivability in contested environments. Stingray provides real-world effects and generates contested RF environments akin to those anticipated during a great power competition. It standardizes training scenarios and environments across the force, dramatically increasing the diversity of training sets, scenarios, and overall realism, while simultaneously reducing the resources required for field training. Our key transition agencies are listed on this slide. Stingray supports a wide array of use cases including electronic attack, radio frequency record and playback, device replication, and signals intelligence and electronic support training. Its modular architecture inherently supports reconfiguration and adaptation to other use cases. Furthermore, its software-agnostic nature allows for integration with various platforms such as WinTAC, GNU Radio, and a REST API. As a reminder, Stingray is a product of Aspen Consulting Group, a New Jersey-based small business. We currently employ 69 personnel and have reported a 2024 revenue of $36.6 million. Our main office is located at 1500 Meeting House Road, Seagirt, New Jersey. More information can be found at www.aspenconsultinggroup.com. For any technical or programmatic inquiries, please reach out to our points of contact: Steve Pizzo, our Chief Engineer and VP of EW, and Larry Singer, our President. Their contact information is listed on this slide. We invite you to participate in our Stingray electronic warfare training system demonstration to gain a deeper understanding of its capabilities. Thank you for your time.